question number 15 of exercise 6.5. Okay, this is also one of the important questions to understand, a little bit bigger but not difficult. As I told you, if you see so many squares, that means one thing should come in your mind, that the question you have to do with Pythagoras theorem. Now let us see what is given in the question. Here ABC is an equilateral triangle, right? And B is a point on BC such that this BD is 1/3 of BC, right? These two things are given. This is an equilateral triangle and BD is 1/3 of BC. Now what we have to prove? We have to prove 9AD square. This line, right? This line segment. 9 times of AD square is equal to 7 times of AB square. This we have to prove, right? But because I am saying that you have to apply the Pythagoras, so first question which comes in your mind, that there is no right angle, and without right angle how can we apply the Pythagoras theorem? So we have to do the construction here, okay? And you have to think for the construction, because there is no right triangle, so we have to draw a perpendicular here so that we get a right triangle or more than one right triangle, right? How? Let's see. So the construction will be, draw AM perpendicular on BC. So draw AM perpendicular on BC. So this is about construction. Okay? Now we have to see this AD square. This AD square you have to find that in triangle AMD, isn't it? So we'll apply the Pythagoras theorem first in this triangle. So I'm starting the proof and I am taking this triangle in right triangle AMD by Pythagoras theorem. What we have AD square is equal to AM square plus BM square, and let's say this is number 1. Okay, now just look here, AB square, we can get AB in right triangle AMB. So now which triangle we have to take? AMB. So now in right triangle AMB, similarly we can apply the Pythagoras theorem. What we get? AB square equal to AM square plus BM square, right? So we get it from the Pythagoras theorem again, and we have applied the Pythagoras theorem now in right triangle AMB. Now but look here, we want AD and AB, okay, and these equations I have got this AD and AB, but along with that we got so many other things. But AM square is common, so I can remove that easily. So first we have to remove this AM, then further we remove few more things, and then we'll reach to the answer where we have to. That means 9AD square equal to 9AB square. So from this equation, if I want to get the value of AM square, what it will be, take it on this side. So this is the value of AM square. This is number 2. Now from equation 2, I am putting the value of AM square in equation 1. So put the value of AM square from equation 2 in equation 1. So after putting, what we get? We get AD square equal to AM square. Now AM square is this. That means AB square minus BN square. Okay, this is the value of square plus bm square as it is. This is number 3. So we have just removed am square from here. But again we want only AD and AB. We don't want BM and DM. So we have to remove this BM and DM too. So how we have to remove that? We know that this is given BD is 1/3 of BC. Okay. Now BD we have as 1/3 of BC, or we can write as 3BD is BC. 3 times of BD is actually BC. So if BC is X, then if BD is X, if BD is X, then BC is 3X, right? If BD is X, then BC will be 3X. Okay? Now what we have to do? We also know that if in an equilateral triangle, AM is perpendicular. This is by construction we have constructed. So in an equilateral triangle, perpendicular is also the median. That means this is the midpoint of BC. Okay, so as AM is perpendicular to BC, so this implies M is the midpoint of BC, right? And if it is the midpoint of BC, that means BM is half of BC, isn't it? And if I want to get the value of DM, because we want to remove DM and BM, so DM and BM we want to remove, so we want to get the values of DM and BM. Now BM is half of BC and DM I can write, DM I will get from BM minus BD. This is BM minus BD. Now BM is half of BC and BD is 1/3 of BC. We already have, this is given. Now subtracted by taking LCM, LCM will be 6. So 3BC minus twice of BC, that is 1/6 of BC. Now we have DM in the form of BC and also this BM in the form of BC. This one and this one. This is DM. This is equal to DM. Now we'll use these two values. We'll put the value of DM and value of BM here in this equation number 3. Okay? So now put the values of DM and BM in equation 3. We get what we get. Let's see. When I remove this BM and DM, then we'll move ahead so that we'll reach up to AD and AB. Okay, now this is equal to AD square, AB square, BM. What is the value of BM? BM is half of BC. And the square. DM is 1/6 of BC. Right. One more thing we know. What we know? In an equilateral triangle, all 3 sides are equal. We know this. And BC and AB both are equal because these are the sides of equilateral triangle. An equilateral triangle. That's why I can write instead of BC, I can write AB. And why I am writing this? Because to prove I don't want BC, I want AB. So I am just removing this also. I am writing here AB and 1/6 of AB. Why I have done this? Because both of these values are equal. So I can write the reason that triangle ABC is an equilateral triangle. That's why AB and BC are equal. Now solve it. AD square equal to AB square minus 1 by 4 AB square plus 1 by 36 AB square. Okay? So take the LCM here. LCM will be 36. This is 36 AB square. 4 nines are. So it will be 9 AB square and this is AB square. 1 AB square or AB square is the same thing. Now solve it. AD square equal to 36 plus 1, 37 and minus 9. So this will be equal to 28 AB square upon 36, and I can cut this 4 sevens are 4 nines are. So this will be equal to, this 9 will come here, 9 times of AB square equal to 7 times of AB square. So this we have to prove. Okay? Just take a look. I'm recapping the question. Here we have done the construction because of a right angle, and then we'll apply the Pythagoras theorem in which we get AD and AB. After getting the value of AB and AD, I removed AM from that equation. After removing AM,